y is equal to x square plus x minus 4. So this is an explicit function because on the left hand side there is only y. Explicit function. So y is explicitly defined in terms of x. Okay, on the left hand side there is only the y term. Okay, so these are all the functions that we have done so far. Y is equal to anything. So let's say y is equal to sine of x. Y is equal to, basically y is equal to anything. Okay, so the general form of explicit function is this. These are all explicit functions. Now implicit functions are those in which y will not be explicitly defined, but there will be something multiplied with y. For example, if I give you something like this, xy is equal to 1. X times y is equal to 1. Now this is what? This is an implicit function. You will see something will be, either multiplied by y or something added with y. So y will not be, alone on the left hand side. Okay.
Okay.
So it will be like f of xy. This is f of x comma y. So the function is function contains both the variables x and y. Now in this case, how do we find the derivative? Now first way, Anika, the first way is that you could make this, you can convert this from implicit to explicit. Right now this is implicit. First method is that you can convert it from implicit to explicit. So you can get rid of x, you can isolate y. So the first method is you can isolate y. So can you try to isolate y here? Can you
So would I divide both sides by y?
both sides by x?
Oh, yeah, by x because I'm from.
Yes. So you'll get y is equal to 1 over x. That's so now this is now explicit. And now you can find out y prime. That's just one way. So what will this be?
So the derivative of y.
Y prime is equal to then derivative of 1 over x.
Yeah.
Hmm.
So negative x to the power of -2.
Yeah, negative x to the power of -2. And this is also written as -1 over x square.
Okay.
Okay, so this is one way, but it will be not easy to convert every function from implicit to explicit form. Okay, so therefore we need to know the other method. Okay, so the second method is the method of implicit differentiation. In implicit differentiation, you keep the function as it is. So you just keep whatever you have, x times y is equal to 1. Okay, and now we will differentiate it implicitly, and it's very easy. You just have to apply the product rule. Okay, consider this x as something, consider x as a function and consider y as another function, and just apply product rule. So what was product rule, Anika? So first you will write you are differentiating. You know the form of dy over dx, right? When we differentiate a
Mm-hmm.
function.
Yes.
Yeah. So now this time we are differentiating this entire thing, x times y. Okay. And d by dx of 1. So what you will do is you will take the derivative on both the sides. Okay. So you take the derivative on both the sides. So on the left hand side you can apply the product rule, Anika. So what is product rule?
Um, f f prime of x times g of x times g prime of x times f of x.
Yeah, so like this is, if this is your f and this is your g, so you'll get differentiation derivative of x. So like you can write it d by dx of x, derivative of x, right, times y as it is, plus derivative of y times x as it is, right? This is the product rule, equals derivative of 1 is 0, right? Okay, Anika, then tell me what will be this derivative of x with respect to x.
Wait. Wanted
Derivative of x.
wanted turn into one or
1. Yes, yes, 1. So this is 1 times y, and derivative of y with respect to x is just this.
one. Oh.
No, 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 this will just be this dy over dx, or if you want you can write it as y prime. This is nothing but y prime, and this is what we have to find out. So y prime times x is equal to 0, and now just isolate y prime. See, this is y plus y prime x is equal to 0. Can you try to isolate y prime?
So y prime. Wait. So wouldn't y prime x equal to negative y, and then I'd have
Yeah,
to divide both sides by x?
exactly. So y prime x is equal to negative y, and y prime is equal to negative y over x. Okay. Okay. And now now you would be thinking that we are getting different answers. Here we got y prime as negative 1 over x square, and here we are getting this. So how can they be different? Well, actually they are not different. If you put the value of y back from here, if you put the value of y is 1 over x, put this value here. Instead of y, you see this y, put 1 over x. So minus 1 over x, that will be negative 1 over x square. Okay, so
Okay.
this is the final answer, negative 1 over x square. Okay, Anika, but you can leave your answer at this stage as well. Do you want to try some more questions?
Yeah, it's the
Yes.
confusing.
No, it's okay. This is the first time that you're doing this, so it's okay. Uh,
Okay.
when you'll do more
I
and more.
actually I'm sort of confused by the like the dy over dx part.
It's okay. It's okay. You will understand it when we do more and more questions. See,
Okay.
whenever we differentiate, are you comfortable with this notation d over dx?
Sort of.
If not, I think you will be more comfortable with the prime notation.
Yeah.
So let's use the prime notation then. You don't have to use, these are just different notations, nothing else.
No, you mean the same thing, right?
Yes, they are the same thing. So if you have a function f of x, right, and if you want to find out its derivative, so you can either do d by dx of this, or you write f prime x. So they are the same thing. These are just different notations. So we can use the prime notation. Okay, let's try to do x square plus y square is equal to 9. Okay.
Okay.
Now here again, y is not explicitly defined in terms of x. This is not y is equal to f of x, right? This is an implicit function. Okay.
Okay.
So what we will do, we will try to find out the derivative of this whole thing, x square plus y square prime and derivative of 9. Now see, this is not correct to write it like this. The correct way is, d over dx of x
So you
square,
have to take the derivative of both sides?
both sides. Yes, so d by dx, see this d by dx,
Mm-hmm.
this represents that we are differentiating something. And what
Okay.
are we differentiating? We are differentiating this. So this represents differentiation with respect to x. Whatever is in the bottom, that is, we are differentiating it with respect to x. And what are we differentiating? We are differentiating x square plus y square. Okay, and on the right hand side we are differentiating 9 with respect to x. Actually, I should write it like this: d by dx of 9. Okay, so Anika, now this is very simple, this one. You can first differentiate x square and then differentiate, because this is addition of two functions, x square plus y square. Okay,
Okay.
and derivative of 9 is what?
Wait, so
This on the right hand side, this
so
is
wouldn't it be, well, wouldn't it become 0?
0. This is just,
Okay.
this is just 9 prime,
Yeah.
like derivative of 9 with respect to x. Okay, so this is going to be 0. Okay. Okay, now again there will be a new thing that I will introduce you to. So Anika, first, what is the derivative of x square with respect
X squared is 2x.
to x? Okay, now here we have to differentiate y square with respect to x. Now what happens is, Anika, so try to understand this. This might be slightly confusing. If you have a function which is y, this is y, and I am trying to differentiate it with respect to x, so things will be slightly different. See, if you had to differentiate y square with respect to y, right, if it was d by dy of y square, so this is what, this is differentiating y square with respect to y, then it would be simply 2y. The power rule, I have applied the power rule like you would do d by dx of x square. That will be 2x. Similarly, the variable can be anything, right? It can be x, it can be y, it can be z. So if you have d by dz and you have z square, then what will be this?
So won't that be 2c?
2z, yes. We don't have a problem until we are differentiating the same variable with respect to the same variable. Right, now what will be derivative of a square with respect to a?
2a?
2a. So we don't have any problem as long as we are differentiating a variable with respect to that variable. But we have a problem when we do this. Here we are trying to differentiate a different variable with respect to a different variable. So how do we do that? In this case, Anika, we will do first you will differentiate y square with respect to y. Okay, just imagine in your head what will be the derivative of y square with respect to y.
Wait, so with respect?
With
Well, that would
respect
just be 2y, right?
to y. Okay, but right now this is not with respect to y, this is with respect to x. Okay, so then you just multiply it with, first you differentiate it with respect to y, and then you differentiate it with respect to x, and that will be just dy over dx. Let's try another one. Can you tell me what will be derivative of y cube with respect to x? So differentiate y cube with respect to y in your head.
So 3y squared times dy over dx?
Yes, 3y squared times dy over dx. So it does not matter what function you have. Now can you tell me derivative of root y, square root of y with respect to x?
So that would be, wait, 1 over 2y times dy over 2x?
Yes, 1 over 2 root y times dy over dx. Okay, so let's do this. This will be 2y times dy over dx equals to 0. Okay, and remember you have to find out the value of dy over dx. So we will try to isolate this dy over dx. This is your y prime. Okay, so how can we isolate dy over dx? Subtract 2x. Then divide by 2y.
Okay, wait, so then wouldn't it just be negative 2x over 2y?
Yeah, so dy over dx will be negative 2x over 2y, which will be just negative x over y. Okay, now Anika,
Okay.
this question, in the same question you can also be asked to find out the equation of the tangent line. You remember the questions in which we used to find out the equation of tangent line? Okay, so let's do this question. We have to find equation of tangent line to this function at point 2 comma root 5. Do you know, Anika, what will be the graph of this function? We did this in SAT.
It's it like a quadratic
No.
or oh
In quadratic, there will be only one of the variable will be squared. Either it will be just y squared
oh
or
is it the circle?
yes, this is circle.
Okay.
Okay, this is a circle centered at 0 comma 0 and its radius is 3, but you don't have to think about that. Now we want to find out a tangent to this circle at this point. So what we used to do, we first used to find out the slope of the tangent. So we have y minus y1 equals m times x minus x1. We need to find out the slope. And you know what is the slope? Slope is nothing but the derivative of the function.
Yeah. So
So derivative is this.
there's negative x over y. So that's the slope.
That's the slope. So we can plug in place of m. And x1 y1 is this. This is x1. This is y1.
So it'd be oh wait, no.
Hmm.
So y
Minus.
minus 2 or no sorry root 5 is equal to negative x over y
Hmm.
times x minus 2.
Yes. And you can simplify this, or if you want you can leave it like this. It's better that we bring y on the left side, like we isolate y on the left side. So let's try to do this. So we distribute this, so this is negative x square over y plus 2x over y. No, I think multiply by y on both sides, multiply by y, multiply by y. So what do you get? Y square minus root 5y negative x times x minus 2. Oh, wait. I forgot one step. When you have to find out the tangent at this point, Anika, at this point 2 comma root 5, so you, after finding out the derivative, you also substitute that point in the derivative, right? So you plug in the point 2 comma root 5 in the derivative. This is your final derivative. You plug in the point 2 comma root 5 here.
Wait. So wait, so I have to plug that in
In the
for the
derivative.
slope?
Yes, the slope will
Okay.
be a number, right? It will not be like,
Right. Okay.
yeah. So negative 2 over root 5. Okay, now this is a number. Now negative 2 over root 5 will be a number, and this is m. This is the value of m. And now we can plug in everything here. So y minus root 5 equals negative 2 over root 5 times x minus 2. That's your tangent.
Okay.
Okay, now let's do two questions and then I will introduce you to higher order derivatives. We'll do this until you feel confident, okay? Okay, let's try to differentiate x cubed times y raised to 5 plus 3x equals 8y cubed plus 1. Okay, so
Okay.
take the
Um,
derivative on both the sides.
so 3x squared plus
3x squared.
5y to the power 4.
Now here you're applying product rule, right? See,
Oh, yeah, in that section.
so first you differentiate this x cube, you get 3x square, and you keep the other function as it is, plus your derivative y raised to 5. Differentiate y raised to 5, what will that be?
5y to the power 4.
Times dy over dx, and the other function you will keep it as it is. I hope this step is clear.
Wait, but it's product rule, so wait, now I am confused.
See, this is product rule, and what is product rule? This is f, this is g. So you first you differentiate f. So when you differentiate f, you get 3x square, and you keep the g as it is, and you do plus, then you differentiate g. So this is what? This is your g prime. G prime times f. And this is what? This is your f prime times g. What is
Okay.
the derivative of f times g? It is f prime times g plus g prime times f, right?
Yes.
So that's what we have done. F prime is 3x square and g is y raised to 5, and then g prime, which is derivative of y raised to 5, that will be 5 times y raised to 4 times dy over dx. You remember we are differentiating y raised to 5 with respect to x. So this is a problem. We cannot differentiate one variable with respect to another. So you first differentiate y raised to 5 with respect to y, that will be 5 times y raised to 4, and then you multiply it by dy over dx. So that is your g prime. Okay, Anika, I hope this step is clear.
Sort of.
Sort of, it's okay. It will become clear when you practice more and more questions. Okay, so this is derivative of the first term, then derivative of 3x.
And then, okay. So, and for 3x, will it just be normal and, like, will it just be 3?
3, yes, derivative of 3x. Remember, we are differentiating everything with respect to x. So derivative of 3x with respect to x is 3. Now derivative of 8y cube.
So here will it be like 24y squared times dy over dx?
Yes, exactly.
Okay.
4y squared times dy over dx. And derivative of 1 will be 0. So I'm not writing plus 0. Okay. Now let's write this properly. So that you have 3x square y raised to 5 plus 5y raised to 4. I'm gonna take this x cube here times dy over dx plus 3 equals 24y square times dy over dx. And our answer will be the value of dy over dx, because that's what we are trying to find out. We are differentiating the function y with respect to x, so we need to isolate dy over dx. So you see here you have dy over dx, and here also you have dy over dx. Okay, we want to isolate this.
Okay.
So how will you isolate this? Just, think of it like solving an equation like this: 3 plus y plus 3 equals to y. So if this is an equation and you want to isolate y, then how would you isolate y?
Um,
Okay, this is 5y, this is 24y. So if you had a normal equation like this, and if you had to isolate y, then what would you do?
okay, wait. So for this, I have to add 5y to 24. Well, subtract 5y to 24y.
Exactly.
And so now it's 19y is equal to 3x plus 3.
Yes, so you would get 3x plus 3 is equal to 19y. So you said that you would subtract this 5y from both sides, right? So, and then finally we will divide the equation by 19. So 3x over 19 plus 3 over 19 will be equal to y, right? So same thing we will do here. You want to isolate dy over dx. So you subtract this term, Anika, this term,
Okay.
subtract this term, so you'll be left.
So,
Hmm?
wait, never mind.
Yeah, tell me.
Um, so I think I confused myself.
It's okay. So we are trying to isolate dy over dx. So start collecting the terms of dy over dx on one side of the equation, right? So bring all the dy by dx on one side. Okay, bring it on the right hand side so that all the dy by dx terms are together. Okay,
Okay.
so this will be plus 3 equals 24y square dy over dx minus 5y raised to 4 x cube dy over dx. Okay, and now, Anika, we cannot simply subtract these two. In the example that I took 24y minus 5y. So like the coefficient was 24 and 5, it was a number. So that's why we could easily subtract it and we got 19y. But here you see the coefficients are different. This is 24y square, this is 5y 4x cube. So if you want to isolate dy over dx, you can factor it out. So for example, Anika, if you have ay minus by, then how would you isolate y?
Okay, so I would have to well,
Like you can factor
I
out
would
y.
first. Oh yeah, then I'd factor out y.
Mm-hmm.
So then it'd be y times a minus b.
Exactly. So same thing if we apply here and we factor out dy over dx. So you'd get dy over dx times 24y square minus 5y raised to 4x cube. Our goal is to find out the value of dy over dx. Okay, that's our goal. So this left hand side is as it is. Now, what happened?
Um, Sorry.
Okay,
Um,
okay, then what?
Wait.
Yeah, what happened?
Oh, okay, wait, that makes sense because it's like the same thing because they're both like y.
Yes,
Okay.
and dy by dx is present in both the terms. Now, how can you isolate dy by dx? Get rid of this.
So that would become the denominator on the other side?
Yes, so you have 3x square y raised to 5 plus 3 divided by this whole thing, 24y square minus 5 y raised to 4x cube equals to dy over dx, and that is your final answer, derivative of y with respect to x.
Okay.
And this is the hardest problem that you can get.
Oh, okay. That's why it was confusing.
Yeah, so let's do one more problem, Anika. If you're clear with this, then I think higher order derivatives and differentiation of inverse functions will not take much time, but this is really important to be able to do implicit differentiation. Can you try this? X square times tan y plus y raised to 10 times secant of x equals to 2x.
Oh,
Okay.
okay, so 2x
Hmm.
times 2x times secant 2 secant y or wait no
No, so
2
first you're
secant
doing f prime times g, product
oh
rule. Yes?
so 10
I'll write
y
product rule here. Okay, f prime times g plus g prime times f.
and then secant 2 y times 2x.
No.
Oh
What will be
wait
the
2x
to what?
times 10y
Yes.
plus secant 2y
Hmm.
times 2x.
No, you keep f as it is.
I mean, oops, I don't know. I kept saying, yeah, x squared.
And you are forgetting dy over dx.
Oh, right.
Okay, remember whenever you are differentiating a y variable, this is tangent, this is a function of y. So whenever we are differentiating a function of y with respect to x, so dy over dx will always come. So this is this is your g prime, this is your g prime, and then times x square. Okay, now let's differentiate this one. This is f, this is g. So f prime times g plus g prime times f. See, for derivative of this is all of this. Now we are finding out derivative of this term.
Okay, so then it's 10y to the power of 9 times secant x.
Times dy
Um,
over, you again forgetting dy over dx. This is a y function.
oh, right, sorry. And then that would be
Times secant.
times secant x,
Hmm.
and then plus secant x times tan x
Secant x times tan x.
is equal to x squared, or
So you forgot f.
oh, f is y to the power of 10.
Y to the power 10. Okay, and then is equal to derivative of 2x.
X s 2.
2. Okay, so we have this. Now we will try to club the terms in which we have dy over dx. First let's write this properly. So 2x times tan y plus this is x square times secant square y times dy over dx plus 10y raised to 9 secant of x times dy over dx plus secant of x times tangent of x times y raised to 10 is equal to 2. Okay, Anika, so you collect all the terms together in which you see dy over dx. You have dy over dx here, and we have dy over dx here. Good that we don't have it on the right hand side. If we have it on the right hand side, then it would be really long. Okay, so good thing is that they are already together. So you can just factor out dy over dx and rest everything bring on the other side. Like this term goes on the other side, this time goes on the other side. So remember your goal, we are trying to find out the value of dy over dx. Yes, Anika, so you try to factor out dy over dx from
So,
these two terms.
okay, so then wouldn't it just become dy over dx
Hmm.
times, like parentheses,
Yeah.
x squared times secant squared y plus 10y to the power of 9
Hmm.
times secant x?
Yes.
Okay.
And rest everything, you just bring it on the other side. So other side you have 2 minus this term. So basically I'm subtracting this term and this term, then minus secant of x times tangent of x times y raised to 10. And then what will be the value of dy over dx?
Um, dy over dx will be equal to 2 minus 2x times tan y minus secant x times tan x to the power times y to the power of 10 times, wait, well, no, minus,
Hmm.
not minus, divided by,
Divided by, yes,
wait, divided by x squared times secant squared
yes,
y plus 10 y to the power of 9 times secant x.
yes, that's it.
Okay.
This is the derivative of y with respect to x. Okay, let's do one more. 3 more minutes. Okay, now we will take, so this was problem number 4. The more you will practice, Anika, the more confident you will feel. Okay, so this time we have e raised to 2x plus 3y. Now this is, I'm also including composition now. Then x square minus ln of xy cube. Now you'll have to apply chain rule as well. Okay, let's think about this, Anika. We will differentiate, we will take derivative on both the sides. So what will be the derivative of e raised to 2x plus 3y?
Will it still be e raised to 2x plus 3y?
Yeah, so chain rule. Remember chain rule?
Oh, okay. So then e to the power of 2 plus 3? Oh, wait, no, because there's a y there.
Hmm.
Oh, this. So, will I have to do like dx?
So first, this is, first of all, this is composition of function, right? The original function is e raised to x, and instead of x, they have given 2x plus 3y. So you remember chain rule, first we differentiate the function like just as it is. See, if you had e raised to just 2x, then what would be the derivative of e raised to 2x, Anika? Using chain rule?
Um, would it be just e raised to 2?
No, e raised to 2x times the derivative of the inner function. This is like if you have f as e raised to 2x, sorry, f is e raised to x, and g is 2x. So this is composition of f of gx. That's how you're getting e raised to 2x. We have replaced x by 2x. Okay, and how do we find out derivative of composition function? We first take the derivative of the outer function times the derivative of the inner function, right?
Right.
You forgot the chain rule?
No, I'm just confused because I thought with exponents it stayed like, well, not exponents, when it was e, it stayed like the same way.
Yes, it will stay exactly same way. So derivative of this thing will be e raised to 2x plus 3y. It stays the same, times the derivative of whatever you have, like
Okay, so times
hmm,
2 plus
hmm.
3? Or because it's y, will it be 3 times d of x over dy?
Yes, dy over dx. Good.
Okay.
Okay, then let's differentiate the right hand side. So derivative of x square will be
2x minus,
now derivative of ln x.
so that's usually 1 over x.
Yes,
So, but now, because, so will it be 1 over x
yes,
times, or time, because it's, this is
yes, you're
times,
right.
okay. So 1 over x times
1 over this thing, 1 over 1 over x, 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 1 over 1
x,
times
right?
derivative of xy
Um,
cube.
times 3y squared.
Now what will be the derivative of the inside function? This is,
3xy squared.
so you'll apply now product rule, right? This is product of two
Oh yeah.
functions.
Okay.
Yes.
Um. So then it'll be x times no 1
Hmm.
times y cubed.
Hmm.
Um.
Plus,
Plus plus 3y squared times dy over dx times x.
yes.
Okay.
Okay. And now what you have to do, you have to collect the terms in which you see dy over dx together. Okay. You see this is one term where there is dy over dx, and this is one term where you have dy over dx. So now it's all algebra. The calculus part is
Right.
done.
Is over. Now this is algebra. But
Hmm. Okay, so we see that there is this term that is dy over dx, and this term, but is first I think you can you'll have to distribute this. So distribute this e function inside. So you get 2 e raised to 2x plus 3y plus 3 times e raised to 2x plus 3y dy over dx equals 2x minus, distribute this. So when you'll distribute this, you see this y cube will get cancelled. See this, when you multiply this by this term, y cube and y cube will get cancelled. So this will be 1 over x minus 3y square. So this, when you multiply this by this, x will get cancelled, and this will be 3 over y times dy over dx. Okay, Anika, now you can collect, just bring the dy over dx terms together. I think you
okay,
can
wait.
do this now, right? We don't have to finish
Um,
this.
I think so. Well, wait. How do I
Hmm.
get? Would I have to divide it by dy over dx to get it like to the other side later on? Because that's times, right?
So first you bring either this term on the right side, or you bring this term on the left side, and all the
Okay.
other terms on one side. So bring this term, and these two terms should be on one side.
Okay.
Okay, so the red ones on one side and the green ones on one side. So 2 times e raised to 2x plus 3y. Bring the this 2x minus 1 over x on left side, so it will be minus 2x plus 1 over x equals to, bring this one on the other side, so minus 3 over y dy over dx minus 3 e raised to 2x plus 3y times dy over dx. Now you can factor out dy over dx. When you factor it out,
So dy over dx times negative 3 over y minus 3e to the power of 2x plus 3y. And then I
yes,
have to divide everything by that.
yes,
Okay.
that will be your answer. That will be the value of dy over dx. Anika,
Okay.
now I'll be assigning you questions on implicit differentiation on IXL. Now I want to review
Okay.
your IXL questions. I think after the last class you did you
I
part
mostly worked on the sine ones. I haven't um finished much. I was working on trig functions.
Okay. We had our last class on 30th September. Okay, after that, I think you practiced on 1st October. I think you've practiced on 1st October after 30th. And this is the skill, find derivatives using the product rule. Your smart score is 76 and you missed 6 questions. So I had opened this. These are the questions that you missed. I think we reviewed this question in the last class, e raised to x cosine x. These are the questions that you missed. Mm, can you do these questions now? I think you can do these. This one is,
Yeah.
I think now when you've done implicit differentiation, then this will seem very easy.
I kept placing things the wrong way.
Okay, at the first one we discussed, the second one you made a mistake. No, this is fine. Even if you're changing the order, like x raised to 5 times sine x, you can write it as sine x times.
Because I
But
kept it as plus, not
yeah,
minus.
that is the wrong thing. The mistake is this, that the sign is different, but you can change the order, that's fine. In this question,
I accidentally kept equal to instead of
yeah,
minus.
this is a typo
The
because
typo.
the equal to and minus sign, they are
Yeah.
together
They're right
on the
next to there.
yeah.
Yeah.
And here what happened? You forgot you
I kept x in front of sine.
oh, derivative of x is just 1, so okay. No, but these type of mistakes happen when we are learning differentiation for the first time. But the more you'll practice, because you know what mistake you're doing, it's not like you don't understand this at all. You understand this and you know what mistakes you're doing. So it's just about the amount of practice. Okay, so this is here you again, I think you placed x. So you have to be really clear, Anika, with derivative of sine and cosine. Derivative of sine is positive and derivative of cosine is negative,
Okay.
right? And what about this one? X times e raised to x.
I think I was just confused for
Okay,
that one.
let's do it right now. Okay, Anika. X times e raised to x. X times e raised to x. So apply the product rule. This is f, this is g. So f prime times g plus g prime times f. It will always help you if you write the product rule on your scratch paper or wherever you're doing. Okay. Okay, so
Which
this will be
1 times e of x plus e of x times x. So that's equal to ex plus e of x times x.
hmm?
I'm getting e of x plus e of x times x.
Yes, that is correct. E of x plus e of x times x, that is correct. I think e of x plus x times e raised to x. Okay, Anika. I will assign you questions on implicit differentiation. Practice those questions, okay? If you practice questions of implicit differentiation, you'll automatically get practice of product rule, practice of chain rule, that you will automatically get, okay?
Okay.
And tomorrow we'll have class at 9 p.m. We'll
Yeah,
do
9
higher, yeah, we'll do higher order derivatives and derivatives of inverse functions. So here you have find derivatives of implicit functions,
Okay.
finding tangent lines using implicit differentiation. Okay, this one I have not taught you. The finding derivative using logarithmic differentiation. So today you have to do only I1 and I2. I have assigned it to you, I1 and I2 on IXL.
Okay.
Okay, Anika, then I guess I'll see you tomorrow.
Okay. Thank you so much, Miss
Okay.
Rinda.
Thank you, Anika.
Bye. I'll
Bye.
see you tomorrow.
See you tomorrow.